Hello and welcome to my complete maths course. This course will teach you from scratch how to become a mathematician and successfully enable you to pass exams in school and beyond school. It's been the work of 20 plus years of tutoring, learning and lots of experience to make maths easier. It's something I set out to do in the year 2000, 2001 to help students really understand maths. And over the years my course has evolved to create advanced methods, make it simple and easy to understand and remember because it's in context, and be enjoyable. I've been tutoring for those 20 years and I've taught hundreds of students, most of which struggled with maths, struggled to get the grade they needed at school, and I have a 95% success rate. I've written down a few of the things that I've discovered or innovated to help students, and I'll just go through them now. So the first one is probably the most important. An easier way to multiply that can be used in 11 different areas of maths that I've found so far. So you're probably familiar with quite a range of techniques just to multiply two numbers together, but I'm going to show you today how to do that far more easily and without any working. In fact, we're just going to write the answer down. Next, 3 simple rules to learn that are repeatedly used in all levels. So even from the start, we're going to learn these 3 rules. And it doesn't matter what level of maths you do, you'll always end up using these. But most students don't know them. Finally understand why we do algebra. So you might think, well, we do algebra to find x. Yes, but why do we try and find x? That's the question. And most students don't know this. In fact, a lot of teachers don't know this. So this course will also answer that question and show you why we do it. Use the same concept to do indices or multiply decimals. So this is one of the rules which we'll come to in this lesson. And there are 2 things that appear different, multiplying decimals or doing indices, uses the same rule. And the point about this line is that a lot of things in maths are connected, and in school they're taught as if they're all separate. But the goal of maths is to see things that don't appear to be connected and connect them. So that's what this course does. Subliminal teaching of algebra and calculus, which makes them easier to explain and understand. So as the course goes on, I'll teach you what you might think are normal concepts, but within that I will be preparing your mind for algebra. So when it comes to algebra, or it comes to calculus, I'll just ask the same questions again I asked you for the number stuff, and you'll know all the answers already. Alternative quadratic formula to solve their equations easily. So if you've done more advanced maths and you've done trying to solve a quadratic and you've used the famous formula, I'm going to show you a different one which gives a better understanding of it and more information, and it takes no more effort. Solve percentages in your head or in a few seconds on paper. So this is something like finding 41% of 32. So normally that at school they'll do 10% is this and 1% is this, and then we'll try and find 41% by combining them. I'll show you how to do all that in 5 seconds. Unique explanation of trigonometry and how it works. So again, at school they have famous SOHCAHTOA, but why? Where does that come from? So we're going to look at, for that, the importance of tangent. Why is tangent the most important one? Did you know it was? Then sine and then cosine, what they are, what they mean, and so on. So I've got some more down there, but we'll come on to those in the future. So let's start. So starting at the beginning, we're going to begin with times tables. So we're just going to write a few. Now, before we do any of that, there's two things I need to tell you, which is one, when I ask a question, obviously I would normally have a student and they'd answer back, but can't do that in this situation. So if I ask a question, just pause the video for a moment and think of the answer yourself. In the early lessons, you might be able to do this in your head. As they continue, you might want to get a pen and some paper and take the time to do the question, think about it for yourself. Sometimes it'll just be a verbal thing, and sometimes it'll be a question you've never heard before, and you might not know, but that doesn't matter. The point about that is you need to try and figure it out. Second, if I'm explaining something and you don't understand it, that's my fault. So, not yours. So, if you've watched a video and you feel you don't understand it, just put it in the comments, the part you don't understand, and in the future I'll try and make a video to explain that in a different way, and I'll leave that video, the link of the video in the comments for you to find later. Okay, so let's begin. So I'm going to ask questions now, and I want you to pause and answer before I write down the answer. So, what's 3 times 5? So pause and think of the answer. Okay, 15. 4 times 6. Pause. Okay, 24. 5 times 7. Pause. Okay, 35. 6 times 8. 48. 7 times 9. 63. And 8 times 12. 96. Okay, so we've done some multiplications there, but the question I want to ask you is, without using the words multiply or times, what is multiplication? So have a think about that by pausing the video now. So if we did 3 times 5, we're doing a multiplication, and you might think, right, well, multiplication is when you times two numbers together. Well, you use the word times, okay. It's when you have two numbers and you do something and you get an answer. Well, that could describe anything. So, what is multiplication? It's repeated addition. When we do 3 times 5, what we mean is add 5 3 times. That's where the word times comes from, how many times we add, so 3 times 5. A more old-fashioned way of saying it would have been 3 times we add 5, but as time's gone on, that was dropped, so it's just 3 times 5 is what we say. But we mean add 5 3 times. So when we look back at the multiplications we've done there, we'll see that's the case for all of them. 4 times 6, add 6 4 times, 24. 5 times 7, add 7 5 times, 35, and so on. Okay, so multiplication is just addition. Now I call this the first rule of maths. And there are only 3 rules. Those 3 rules I spoke about in the introduction. Multiplication is just repeated addition. But I don't repeat the word repeated. So multiplication means add over and over again as many times as you're told. So 3 times 5, add 5 3 times. Next question. When we multiply 2 numbers together, what shape do we get? So pause and think about that, please. Right, well, when we multiply 2 numbers together, like 3 times 5, that means add 5 3 times over. Now, you might think, well, what shape does it get? Shape, what do you mean? So if I drew out 5 dots, like that, that's the 5 dots, and I add that 3 times over, so I've got 3 5s or 15 dots. What shape has it given us? Well, a rectangular shape. So when we multiply 2 numbers together, we get a rectangle. So if I do it with squares instead, then there's 5 squares, and then here's another 5 squares, and here's another 5 squares. Whoops. And you see that altogether we've got 15 squares. So that's why it gives a rectangle, because 5 plus 5 plus 5 is given a rectangular shape. What happens if we multiply the same number by itself, like 3 times 3? What shape would we get then? Pause. So in this case, we would get a square. So 3 times 3 would be 3 lots of 3, so this would be this one here. 3 lots of 3. So that gives us a square shape. In fact, that's why it's called squaring. When you multiply a number by itself, it's called squaring. Why? Because you get a square. So if we're multiplying different numbers together, we'll get a rectangle. So we might think of that as being called rectangling, but we don't call it that. But effectively, that's what we're doing. Okay, so next question. When we multiply 2 numbers together, like 3 times 5, what information does it give us about the rectangle? So pause there. So the information we get is how many squares are in the rectangle, right? So we get 15, and that's how many squares are in this rectangle. Now the name for that is area. So area is just how many squares are in the rectangle. In this case, it's 15. Now, if I was to measure these squares, so let's say this was 3 meters by 5 meters, then one of these squares would be just 1 by 1 meter. So they would be literally a meter square. That's what it is, a square meter or a meter square. And how many are there in this rectangle? 15. So that's why the area of the rectangle is 15 meter squares, because that's how many squares can fit into the rectangle. So the definition of area is what? Pause there. Now, I've heard quite a few things for this, but a definition of area really might be, say, the space inside a shape. Okay, yeah. But how do you measure that space? And the way we measure it is how many squares fit into the shape. So it's how many squares, so in this case it's 15. And, importantly, what size are the squares? Okay, so we need to say both how many squares and what size. Okay, cool. Now, if you just cast our mind back to 8 times 12 is 96, have a think about how you got that. How did you calculate it? Did you know it, or did you have to figure it out? So just pause there for a second and think about that. Well, you might have done, what a lot of people do is they'll break up the 12 into 10 and 2, and then multiply the 8 by the 10, which gives 80, and multiply the 8 by the 2, which gives 16. So in total that adds up to 96. So next question, what do brackets mean? So pause there. Now brackets are I often get told that brackets mean do what's inside first, but is that what we've done here? Did we do 10 plus 2 is 12 times by 8? No. What did we do? We multiplied 8 times 10 and 8 times 2. So that implies that brackets mean multiply. And that is a far more useful definition of brackets, as you'll see as we go along. Right, so now I'd like to show you how to easily multiply numbers together that are bigger than the ones we've done so far. So far we just did single digit, 3 times 5, 4 times 6 and so on. So now I want to look at some bigger numbers like 14 by 21. To do this, you might have your way of doing it, the grid method, Chinese method, Russian method, long multiplication, whatever. But I'm going to show you an easy way. And the reason it's easier is that we'll just get to write the answer down in one go with no working. So that's the first thing. And the second is it's applicable to other ways of doing other things in maths. Like I said at the start, we get to use it in 11 different places. And you'll find you'll achieve a fluency doing this where you might even end up doing them just for fun. So, to show you this technique, it actually has 3 steps. So I'm going to write out each individual step. So, step 1 is we multiply the right-hand column. So 4 times 1, 4. So when it comes to step 2, we've already got 4. Step 2 is what you might never have seen before, is we're going to put a cross in the middle like that, or we can just imagine it, and then multiply along the lines of the cross. So we do 4 times 2, which is 8, and 1 times 1, which is 1. And then what we do is, because multiplication is just addition, is add those 2 answers together. So 8 and 1 make 9. So far we got 9, 4. And the final step is just multiply the left-hand column. So 1 times 2, 2. Finished. What do you think of that? That's the technique. Just write the answer down. No working involved. Just right-hand column, cross, left-hand column. Let's try another one. So 41 times 32. So I'll talk you through this. So first step, 1 times 2 is 2. Then the cross. So we have 4 times 2 is 8. 1 times 3 is 3. 8 plus 3 makes 11. So here we put 1, carry 1. Finally, left-hand column, 4 times 3 is 12, plus the 1 makes 13. So I've just written the answer down with no working. Let's try another one. 21 times 81. So why not pause it there, have a go yourself. Right, so right-hand column, 1 times 1 is 1. Then the cross, 2 times 1 is 2, 8 times 1 is 8. Add them together, that gives 10. So 0, carry 1. Notice the number reads diagonally, see, 10. And finally, 2 times 8, 16, plus 1, 17. 1701. Let's try another one. 21 times 37. Pause it there, have a go. Right hand column, 1 times 7, 7. Cross, 14, 2 times 7 is 14. 1 times 3 is 3. Add them together, that makes 17. Left hand column, 2 times 3 is 6, plus 1, 7. So 7, 7, 7. Let's try some larger numbers, like 51 times 31. So, have a go yourself. 1 times 1 is 1. then the cross is just going to be 3 and 5 makes 8, and then 5 times 3, 15. 1581. Normally I'd ask my students, have you got any questions? And normally they go, no. That seems okay, that seems good. Sometimes they'll say, okay, what about 3-digit multiplication? Because that's fine for 2-digit, I get that. But what about 3? So for 3-digit, like 412 times 121, we actually have to do 5 steps instead of 3 because there are 2 extra numbers. So I've got to write this out another 4 times. So let me just do that. Now the good thing about this method is that you already know how to do it because I've shown you. It's going to be the same even though there are more numbers. So you can probably guess what the first step's going to be. Yep, a right hand column. So 2 times 1, 2. So when it comes to the second step, we've got 2 already. What will the second step be? Of course, same again, cross. So we do 2 times 2 is 4, 1 times 1 is 1. Add them together, that gives 5. So far we've got 5, 2. Now when it comes to the third step, that's something new, and I call it a Union Jack situation. Although you might prefer to think of it as a snowflake. But because I'm English, I naturally see a Union Jack there. And what we're going to do there is those 3 lines. So we're going to do that, that, and that. So we're going to do 4 times 1, which is 4. 2 times 1, which is 2, and that makes 6 altogether. And 1 times 2 is 2, and that makes 8. So far we've got 8, 5, 2. So what's going to be next? Well, there's quite a bit of symmetry in multiplication and maths in general. So if we look at what we had so far, we've had a right-hand column, right-hand column there, then the cross, then the Union Jack. So the last steps are just doing it in reverse. So we do another cross now, and since we've done here, we now do here. So it's 4 times 2 is 8, 1 times 1 is 1, and that makes 9. And so far we have 9, 8, 5, 2. And the final step is going to be the same again for the 2-digit method. So just left-hand column, 4 times 1, 4. So 4, 9, 8, 5, 2. So hopefully you can see the symmetry in this. So furthest away is the columns, then the crosses, and then the Union Jack. And the Union Jack is itself a symmetrical shape. Okay, so I appreciate that since you've never seen this before, this might seem a bit quick to be doing 3-digit multiplication. Think, well, I'll never remember how to do that. But if you practice the 2-digit ones, the 3-digit ones become quite easy afterwards. So let's try another 3-digit one. So let's say 311 times 212, for example. So first step, same as always, right-hand column, then the cross. So 2 and 1 makes 3. Now the Union Jack. So we've got 1 times 1, 2 times 1, 3 times 2. So that's 2 times 1 is 2, 1 times 1 is 3, and 3 times 2 is 6, that makes 9. Then the cross here, 3 times 1 is 3, 2 times 1 is 2, that makes 5, and then left-hand column, 3 times 2. And there we go. So again, we've done the multiplication without writing any working down, just writing the answer down. So it seems a bit like magic. Right, I'll leave that lesson there for today. If you have any questions, get in touch. You can either do it using the comments or just get directly in touch. You'll find me on the internet. Hope you enjoyed the lesson.